That means that it's the 68%, 95%. Sometimes they include the decimal digits after that, but usually they just use the rounded one. Okay, and then 90 what, everyone? 97.9, right? Sometimes I forget it too. Can you guys remind me? 99.7, sorry. Yeah, it's the 99.7%. Okay, and there's another one is the 99.9%. Usually you just they just focus on the first three. Okay, and you can only use this rule for a normal distribution when the histogram looks like a bell or it's bell shaped. Okay, but if skewed, then you cannot use this rule at all. Okay, all right, so let's look at the first case, the 68% case. Okay, this means that if you are given the distribution like this, the normal distribution, okay, it has to be normal. All right, so let's say I'm going to give you the mean. We can use the mean mu, or you can use the X bar. Either way is okay. Let's say the mean mu is 90 and the standard deviation, this is the mean, okay? This is the mean, okay? And this is the standard deviation. The standard deviation is 2, okay? So let's say the mean is always at the center of the distribution. The mean mu, in this case, is 100, okay? And I'm going to say that 68% of the data values of a data set, if it's normal, are within one standard deviation of the mean. So this is within one standard deviation. Okay? If you don't remember, write it down again. What is the value right here? Everyone calculate it for me. And what is the value on the right? Go ahead and calculate it for me and type in the chat. I got Uriel. Uriel, where did you go? I called on you and I did not hear you. All right, yeah. So what is the number on the left here, everyone? Can you guys tell me? Sometimes the mean can be the X bar, everyone. If it's the sample and if the standard deviation of a sample is going to be the S, okay? So make sure that you know that. We can use this rule for the population or for the sample. All right, so to find the number on the left, you just take the mean minus the standard deviation, is that right? Which is 2. So the answer is what? 90? Is 98, is that right? So it's the same as you have to take the mean mu minus 1 standard deviation, okay? How about the number on the right, everyone? The number right here, can you guys type in the chat for me? Now you should be able to do it. I got Zahid's. All right, Gabby. Good. All right, so for the number on the right, you just take 100, which is the mean, you add to the standard deviation. Is that right? So the mean added to the standard deviation, which is 102. So you can set that, and you can say that 68% of the data values, or you can say of the data, are within the range of, you can say that, the range of 98 and 102, okay? And that's how you do it. If they ask you the two numbers that the 68% of the data are within, then you say that it's the 98 and 102, okay? So that is the first case. All right, let's move on to the second case. The second case is the 95%. All right. And this case is within 2 standard deviations of the mean. Okay. In this case, you also have a normal distribution, and we use the same mean and the same standard deviation. Okay, so let's say the mean is 100, and then if you go to the left, 2 standard deviations. What is the number right here, everyone? Calculate and tell me. Number on the left. Calculate and tell me. We use the same mean and the same standard deviation. Okay. Okay, calculate the number on the left and then type in the chat for me. All right, what's the answer, everyone? I got Zahid's. How about other people? Move to the left 2 standard deviations and move to the right 2 standard deviations. That means that 95% of the data values are within these 2 values. Okay, so to get the number on the left, you have to take the mean minus 2 times the standard deviation. Okay, which is 100 minus 4, which is 96. And this is the same as the mean minus 2 times the standard deviation. Okay. All right. So now let's move on to the number on the right. Go ahead and type in the chat for me to see what you guys get. What is the number on the right, everyone? All right, I got Zahid. How about other people? I will randomly call one person. Gabby, Jennifer. All right. How about other people? Rihanna. All right, so you just take 100 added to 2 times the standard deviation. Is that right? Which is 100 plus 4, which is 104. Okay. All right, Kira. So this means that it's a mu plus 2 times the standard deviation. Okay, so that's the second case. All right, let's move on to the next case. How about the last case? It's not really the last one. It's the 99.7 case, and this is within 3 standard deviation. Okay, that means that if you are given the normal distribution, and here is the mean, okay, and then this is the standard deviation, this is the 100, which is the mean, right? And 99.7%, that means that from the mean, you move to the left 3 standard deviations, and you move to the right 3 standard deviations. So that means that 99.7% of the data values are within 3 standard deviations of the mean. Okay, so what is the value right here, everyone? Type in the chat for me, the one on the left. Remember that here we have the, you move to the left 3 standard deviations. What is the number on the left at the border of the area right here? How about Juan? Can you tell me what do you get for the number on the left?
I'm not sure yet. I'm still.
All right. So here, if you follow me, you have the 100 as the middle number. Is that right, Juan? And if you move to the left, 1, 2, 3, that means that you have to subtract what? You take 100 minus 2 times how many? 2 times what? I mean 3 times what? 3 times the standard deviation. Is that right? You move to the left 3 times. And 3 times of what? 3 times of the standard deviation, which is 2. So that means that is 100 minus 6, which is 94. Okay. All right. Let's see. What is the number on the right? I got the hits already. I will randomly call one person. What is the number on the right? When you move to the right, then you have to add. So what is the number on the right? I got Gabby's, Louis, who else? Nadellen. All right, Evelyn, good. Angela, good. All right, so you just add, right? You just add the mean and 3 times the standard deviation, right? You have to move to the left 3 times of the standard deviation. So it's going to be 100 plus 6, which is 106, okay? So you can say that 99.7% of the data values are within 94 and 106, okay? All right, the last case, make sure that this case, you should be able to do it already. So the last case is 99.9%, and this is within 4 standard deviations of the mean. So if you have the normal distribution, and the mean is always in the middle, okay, and then this is 100. And if you move 1, 2, 3, 4, you move to the left 4 standard deviations, and then you move to the right 4 standard deviations. Then you say that 99.9% of the data values are within this point right here and this point right here. Okay, what is the value on the left here? Everyone type in the chat for me. What is the value on the left? I got Gabby's. You keep subtracting 4 times, right? Right, Alex, good. Yeah, keep subtracting 4 times of the 2, so it's going to be, keep subtracting 4 times, like 100 minus 2, minus 2, minus 2, minus 2, 4 times. All right, good. So now you guys know the pattern already, right? It's a 92. Or you can also take the 100 minus 4 times the standard deviation, and you get the same thing. All right, now you know the pattern. What is the number on the right, everyone? You keep adding 2, 2, 2, 4 times. What is the number on the right? What is the number to the right of the 100? All right, I got many answers from Nadellen, Gabby, Angela. All right, so if you keep adding 4 times, right, 100 added to 2, to 2, to 2, to 2. So it's going to be 108. Or you can also take 100 added to 4 times of the standard deviation 2. So it's going to be 108, everyone. Yeah. You should add like 100 added to 2, and then added to 2, and added to 2, and added to 2. 4 times. 4 times the 2. Okay. So it should be 108. Okay. All right. And you can say that 99.9% of the data values are within 92 and 108. Okay. All right. So those are the 4 cases that you want to review. If you still don't get them, review them many times until you get them. Okay.